This talk is about Scala, Shapeless, cats, kittens, all kind of cute things. And talk itself is also about some cute features they can do with Shapeless cats and kittens right now. So with some real world examples. First, can I do a quick survey? So heard of type level cats? Is that during your class pass? Using it? Cool. And using Scala as that? Cool. All right, so we start with a tiny program or application. It's not that real world, but we start from simple. We have some services at disposal. HR service that can return a number of employees for department, and so on and so on. Budget and extension numbers from different services. And we need to build two functions out of those. One is to get a department out of those services. We need to get a number of employees, budget, and extension. As you can see, all those information are already available from the services. And we build another service, which is giving an employee ID, you can get the extension number for that employee ID. So that's it. So very simple, and everybody knows how to do that without any help from CAT or Scala Z. You just build a function that give an ID, and you build a new department. The problem is that you have bound variables, right? I mean, you have we are doing functional programming. Why we need all this? The first one, you have to pass it in, do all the services and get the value out and then put them into a department. The second one, you have to first call the employee department function, and then you get a department ID, and then you call the directory service extension number method to get the extension out. So we know better, right? We can do function combinator. For the second example, to get an employee extension, we can just combine the two functions, use and then, and you just have two functions combined, and you get one function out. So you don't have bound variable. It's just going to be employee extension. You call the employee department first, and then you call the extension number next. That's it. So great, awesome. What about this one? So you have now. This one is a little bit tricky, right? You're trying to have three functions, and then you have a department apply function. The three functions that you have all takes the department ID, which is simple, but the department case class apply method takes three different arguments. So okay, so then here's what cats can provide. The first thing that cats can provide for you. First introduced cats. It's a library that provides abstraction for functional programming in Scala. So it also trying to provide a foundation for an ecosystem of pure type 4 libraries. So they have, I think right now, dozens of libraries built on top of cats. And also one of the important goals for cats is to provide a respectful and helpful, kind community. It's trying to, provide really help for doing functional programming in Scala. So with cats, the first thing that we can do is say, okay, function actually is just a monad. We can, cats provide a monad instance for function, applicative instance for function as well, so that, as you can see, we can do monadic sequential combination. So the first one is just say, okay, for all these functions, we just use a for loop, a monadic for loop, and then we get the department out, and that's the function for getting a department. You don't have bound variables anymore. And the second one is the one that I actually could probably want to use at this particular scenario, which is associative combination. You just use the apply and Cartesian builder to build three functions. Use the TIE fighter combinator to combine the three functions together into a Cartesian builder, and you map that into to the department apply method function, and then you got a department function that takes ID and then give you a department. So that's awesome. Yeah, cats can do that. So what if the function is asynchronous? The function no longer returns just the value. It's just no longer blocking. It returns a future of integer. So in that particular case, do you fall back to, how many of you will fall back to bound variable? Nobody? Cool. So you probably all know the trick. The trick is cats has this thing called classly, but it's a typical functional programming thing that you can wrap a function, which does not. It's a function from A to B, and instead of a function from A to B, you take a function from A to f of B, and then you can do all kinds of things with this classly and combine them and compose them just like they are a function of A to B. So the example we see here is that you can map, right? Map this classly, and you can create you have a classly from A to f of B, and you have a function from B to C, and you map it, you got a classly from A to C. So that's just the same thing as you map a function. So then we can do the combination again with this class, with the help of classly, right? We can say for associative parallel combinator, we just use the classly wrap each function. And then for each classly, it's applicative, so we can just do the same combination we did before, which is use type-fighter to congregate them together, and then build a bigger Cartesian builder and then map to the deploy apply, and then you finally get a classly out of that, and you call the .run method of the classly. As you can see, the .run is just the field on the top here. It's just the function that the classly contains. So you unwrap that, you got a function from department ID to future of department. So that is neat. And then you can also do and then. So classly has this method that helps you to do and then. So you can do the sequential combination as well. So you do have the and then combination between two classlys. Then you got a classly out, which is, so the two classlys you have is a function for employment department, you basically have a function from employee ID to department ID, and then you have a function from the department ID to extension number, and you just call, and then you got a function or classly from employee ID to extension number. So, okay, so then what if your function has error handling, right? So we just keep making our function more realistic. Error handling with future is actually already baked in, so you can just use the futures baked in error handling as most of the case, but in some cases we want to use either to do error handling. You want, in this particular case, you can see I use a reason on the left of the either side. The reason could be just the ADT, where I have the full list of all the possible reasons that could cause a program fail, and because it's ADT, I can make sure that I handle all of them when I handle them. So that's the beauty of that's the convenience of using an ADT for your own error handling instead of using exceptions, which is what futures does. So what do we do with that? There's this thing called monad transformer provided by cats. So it's called either T. Used to be XOR T, but in the latest cats, we introduced either T. So with either T, you can treat the future of either as this thing called either T, which is a single monad. So then let's look at HR service. If we have this type, we have this either T of future of reason of T, we can just create a new type called reasonable future of T. And that thing is just the either T of future of reason. And that reasonable future is just a monad. And then just like instead of using future, you use reasonable future, which has this error handling baked in, which it's essentially just the future of either of reason and T. So with that, it's the same thing as before. We have a bunch of functions. Instead of returning future of something, we return a reasonable future of something, but they are both just monads, so we can compose them the same way using classly. So that's that. Okay, now we go to the next level. So real-world functions have heterogeneous arguments. They are not. The problem is the simplified things with our previous example is that they all take a single argument, department ID, and but in real world, you have different kind of functions. Each take different arguments, and they have different data presentations. Like in this particular case, this particular example, you can see we have a signed dorm function that it takes a request that has needs three different fields, which is name, sex, and mentor. And we have a register class method, which also takes different kind of data. So how do you compose those or combine those? That's before we do that, we need to do a detour to introduce Shapeless and Kittens. So Shapeless is a type class dependent type-based generic program library. It's kind of mousy, but I can use an example to explain that. And Kittens just built on top of Shapeless and cats. So the example I'm going to use is, first, let's look at genericity by structure. We all know maps, right? The first map is a map between string, the key is string, the value is integer, right? And we know how to work with a map. We can map it, we can iterate through it, we can do all kinds of stuff with it. And the second map is a map from string to string. It's the same thing. We all know how to deal with a map. Doesn't matter how many fields it has, doesn't matter how many items it has, we can deal with the same thing. So what about genericity by shape? So we have two case classes, but if you squint it really hard, it's just like my maps, but they are just different. It's called products. So they have data of different types. They just combine together. Each one, say the department has number of employees, which is integer, budget, which is double, extension number is a string. But it's just a product. It's just combination of several different data. So the same thing goes with students. So idea is that we shouldn't need to write code that is specific to department or student. We should just treat them as we treat maps, just the same thing. So let's continue to look at example. So for example, in cats, we have this type class called traverse, and with traverse, one of the functions traverse provides is called sequence. So if you have FGA, which is f of g of a, and if that g has an objective instance, you can turn that into a g of f of a. Well, that's abstract. So a concrete example is that you have a list of features, right? A list of feature 1, 2, 3. You can sequence them into a feature of list 1, 2, 3, which is a lot easier to work with, right? That's cool. But what if it's not list? It's this thing. It's this department case class. It's a product, right? You have 2, 3 different items of different types. So you have this code that you just extract them out and construct a new department. But what you can do is just say, number of employees is this feature, budget is this feature, and extension is this feature. Let's just do a sequence, and we can sequence out a feature of department, right? That's what generic value combinator is about. So basically, Kittens has this functionality called sequence, exactly as you're thinking. It's sequence against a heterogeneous list, an H list. Basically, if you have an H list of A, which A has an applicable instance, then you can just call sequence and it give you A of the H list. So a concrete example will be a feature of int, H list of a feature of int, a feature of string, a feature of boolean, and you just call sequence, and you get a feature of H list of int to string to boolean, and that the last thing is just nil. It's just the same way you construct a list. So let me see how long I have. So basically, we're back to the code that we just had. What we wanted to do is say, If I have a number of employees, a feature, budget feature, I want to just call sequence and I get a feature of department. And that's exactly what sequence generic in Kittens give you. So you call sequence generic of department, that gives you this, you can say it a combinator, so that you call this combinator with number of employees of a feature of integer, and then you call budget equals the feature of a double, and you have a extension number equals the feature of extension number. You give that to the combinator, it combines that into a feature of department. Does that make sense? Cool. So now we can see potentially this can help us to deal with the combining, how do we combine functions that have heterogeneous or different argument types, right? I mean, this gives you some hint of that. You can see, but before we do that, we need to just introduce Hankin a little bit so that we can introduce our more realistic example. Hankin is basically a very, very tiny library that are just a bunch of couple of experiments based on shapeless cats and kittens. So it has automatic and type-safe data structure transformation and some building blocks for data-type-generic functional programming. So let's take a look. First, we have to define some types. So the whole idea of Hankin K module is, this is one of the modules Hankin provides, is to provide building blocks for generic function combinators. And the core idea is to do that using Classly. And so we start with some type definition. We have abstract types. So Classly must have a so-called result monad, or you have to provide a type called result, which you also have to provide a monad instance for it, but the result can be anything. So then you basically have this type called K, A to B. It's basically a function from A to a result of B. So to make that more concrete, we go next slide, which is we define the result to be either T of an effect and a reason and a T. So this is just basically either T. And the effect, again, is an abstract type, as you see above it. And there's also a reason that is why the application fails. It can be an ADT of failure. So this is a little bit more concrete. So you know the result is always either T. So you have error handling there, but you don't know the effect. And you don't know what particular reason is. So then the next I can make it more concrete in your application. So you can say, for my, you just extend that trait. And you can say the effect is just a future, right? Just that type is just a future, so it's asynchronous. And for the type of reason, you define an ADT, and this ADT just just a seal trait in Scala, and then you have a couple of possible reasons why application fails, like exception happened, or a user error, or unavailable, something's unavailable. So you also provide an effect monad there. Now let's look at a realistic example, Hogwarts student registration. So this is quite some code here, but it's just business logic, so it should be pretty easy to comprehend. But say, I just trying to make it as realistic as possible, so bear with me. We have a type request. The first thing we want to build at the very top is we want to build a K from a request to a registration record. A request is basically a map of string to string. This is passed by the user, so it's basically some random data, not random, like the data input from a user. You can think of as a representation of an HTTP request, whatever. Then you want to get this registration record out. which is some basic information like the name, the address, age, sex, and you need to assign this user, the student, a mentor, we use the mentor service to do that. The mentor service, as listed below, takes in a assign mentor request, right? This request has needs several data. It needs a Wang. You always need a Wang to enter Hogwarts, and you need a special. The Wang is provided for you, unfortunately. So we use the Wang service to provide the Wang, and this Wang service needs a name and address. That's it. And then the last thing it does is to assign you a dorm room, and the dorm room service takes in a assign dorm request, which takes in a name, a sex, a mentor. The reason it needs mentor is that it then try to make sure that people from the same mentor live relatively close to each other, so that they can, I don't know, fight each other. So the first thing we try to build is the basic information from the request, which is a map of string of string. What we want to build is a K from request to basic info. Basic info, again, is just some data about string, about the name, the address, age, and sex. To do that, we first build an extractor, a K, from request to string. Request, again, remember, just a map of string to string. So to get a string out of a map of string for a particular key is pretty easy. You just say request.getKey to result, and the user error is just an error when there's no such key in the map. We use that error. So that's it. The toResult method is a helper method provided by you write there yourself. It's basically when you say request or the map get key, you get an option. You want to turn that into a result, which is either a future of either of reason or the actual string value. You call this toResult method. So cool. So that is easy to write. Now, how do we get from there to extractor from request to basic information? This is the generic function combinator is first introduced here. So you call this compose2 basic information. The compose2 is provided by Hankin K, which is basically just using the kitten.sequence generic. And this one basically provides, the CTBI is basically a function combinator to combine multiple functions or multiple anything actually into anything of basic info. So here's the example. If you have a string extractor of name, you can say, my name is just the string extractor. If you look at the function above, the string extractor name, you just say extract the value of under the key name out of this map. So that's just a K. So the first thing is just like name equals to this K of request to string. And the second thing is also that. And then for age, we just call and then for string extractor of age, basically extracting the value out of the age key. And we say then what we want to do is to try to pass it into integer. We can just do that by using the second function. And then combine them together using and then we got another K of request to integer. And then we can say age equals to that. And then the last thing is similar to age, which is just to get the sex. So then the whole thing is a function of request to basic info. So as you can see, you don't have bound variable here. It's just, you just combined multiple functions into a function that that provides all the relative information needed for the basic info. Still making sense, everybody? Cool. So we can also do automatic parser with Hankin. So if you look at this, this is the manual part. What do you mean by manual parser? Because you still have to compose a basic information parser or extractor or a key from request to basic information by providing name, address, age, and sex, and all the functions do that. But with Hankin.extractor, you can basically provide a function that from the map to, you want to say, giving it a field, I want to get a string value out. So, so the first thing you provide is a way to get a string value out of a map given a key. So that's basically string extractor. So that, again, you can see the string extractor here. Here, you give a key and you give you a request. You give a function that, given a request, extract a string out of it. This is the first thing you provide. And then you provide functions that, giving a string, I want to get an integer, and giving a string, I want to get a sex. So it's string to result of integer, string to result of sex. You provide all those implicitly in Scala. You can use Hankin.extractor to automatically compose extractor from result to request. From request to result of basic information. So it's a K of request to basic information. Again, the K is just a function from request to a result of basic information. You just call this, it automatically compose that for you. So you don't have to manually write, name equals to what, address equals to what. You don't have to manually combine those extractors into one. And another thing that if you have a different data structure, as long as you provide all the primitives of, the thing that you can convert in primitive types, you can automatically get the extractor for that data type or presentation automatically for you. So that's automatic parser with, should be automatic extractor with Hankin. All right. So now let's look at the final application, which we want to combine all the services I mentioned before, which is mentor service, the WAND service, which gives you a WAND, the mentor service assign a mentor for you, and a dorm service, a dorm room service that assign a dorm room for you. So let's look at this. It's going to be quick. It's going to be interesting, but I think it's as concise as can be. So what we want to build is a service. It's a function that from request to registration record. Just to remind you again, the registration record has basic information in it, a mentor in it, and a dorm room in it. So we want a function from request to that. How do we combine function? How do we do that? So remember, the whole thing, each K is just a monad, so we can use for loops. This is how we do it. And the first thing we can get is the basic information extractor. This is the one that we just constructed using auto extractor or the manual extractors. So it's basically this guy, the guy just appeared. We use that here, and we get a basic information out, called BI. So that's why it's from the auto extractors. And then we need to use the mentor service to get a mentor. The mentor service, as you can see above, it requires a WAND and a specialty. So this is how we combine several functions into that mentor service function. We can say the WAND is from, we need WAND service. So the WAND service in this turn needs name and address. Okay, where do we have name address? It's in BI, right? BI has name address. the basic information as name, address. But in this particular Wang service, it takes a different data presentation. It takes a get one request. It also has a name and address. So what Hankin does is provide a convert module that you can just convert from one case class to another case class as long as the origin case class has all the fields the target case class has. So in this case, it is the case. So the get one request has address, name, and the basic information also had those fields. So you can just call two, and now you got a get one request out. And then you can call a pure request. This is pure is the k is classly.pure, so it creates a classly out of a constant value, and then you call and then you combine that with the when service, right? Because now you have a classly of when request. Sorry, have a classly of when request. So you can just call and then you got a classly from request to when, and then. We want to get the specialty. The specialty is just going to come from the request, which is the map. And we use the string extractor again here, which got the value of specialty out of the specialty key. And then we can call string to specialty, which is a function simply convert string value of specialty into enum of specialty. That's easy. So now, with when and specialty ready, we can call the mentor service is ready. We call the control map R, which then is a function from request to mentor now. So basically, everything you see here is just k. A k, you see a k here, a k, then combine enzyme with another k is another k, and here is another k. They just, when you call control map on them, they also are k. So everything is just k, so classless. Then the final one is the dorm service. What we need in a dorm service, we can see is string, sex, and mentor. And so again, we remember that name and sex is also available in the basic information, which is BI. So, but the mentor is not. So this is the case. We want to convert a basic information into assigned dormant request, which has both name and sex, but not mentor. To convert that, we have to provide mentor, so we can call bi.to this new request and call set mentor equals to mentor. Now we get an assignment dormant request out. So this is another function provided by Hankin.convert. If you're trying to convert a case class to another case class, but you don't have all the fields that the target needs, you can just manually set it in the set function. So now you have assignment dormant request case class. And then you call that, you got the function. Then you just combine this to the registration record. Then you got a function from request to registration record. And it's a combinator of all these functions with some Hankin conversion, kind of like glue between the different data presentations needed by those. So voila, you have the final product, and we don't have many bind variables here. And we used function combination as much as possible. And the whole thing is asynchronous, has error handling baked in. So anything goes wrong, you get the error on either side at the very last. And the whole thing you build here is also just a function. So nothing is executed here. So if you want to run it, you can just call register, give it a service, and then you give it, then you call .run, and you give it a request, and you will run that. So it's a description of the application. It's not actually doing anything yet. So all these projects are, except Hankin's, are developed under an umbrella called type level organization, which is a community of projects that an individual organized around pure type for functional programming. So I'm going to just introduce, I just want to give all the credit to type level organization. So questions, but I don't know anything about Hogwarts school, but I have some type level stickers if you want them. No questions? All right, it's a wrap. If you need type level